So this one here, we're going to look at 18 and 19. We'll just focus on number 18 because it's the same type of question. But this is a classic question in calculus, is finding the equation of a tangent line, which is going to then allow us, the reason we really care about the equation of a tangent line, because that tangent line at that point is an approximation for the function, right? So these complex functions all boil down to an equation of a line when we look at those functions at very small intervals. And that's an amazing discovery in calculus, that we can do something like that. That's why this question comes up often. And so here's one of finding the equation of the tangent line. Of course, looking at it graphically is always an important part of the process. But once we understand what we're doing, and we know, oh, we're just going to calculate y prime. And so in this case, your y prime is equal to the inverse cosine of x, right? And so we have a formula for that, which is, again, I always have to think about that. They're related to the sign, but that's negative square root of -1 over the square root of 1 minus x squared, and then it's plus 1 in this case there. And so we're looking at, so that's the derivative. And to find the equation of the tangent, I need the slope. So I'm going to plug in 0 into that, right? So we want y prime. Sorry, again, I'm on an iPad here. We want y prime when x equals 0, and that's what we're going to evaluate. And so you get -1 all over, and I think there was a question on Pronto regarding this. 1 minus 0 squared, which is just 0, plus 1. So I think you end up with -1 over 1 plus 1 equals 0. So in this case, your slope is equal to 0 in this case. And so, which simplifies this thing. And so what we need to then find out is okay, so now that we know it's 0, your slope is 0, add 0. We know that the tangent line has to be horizontal, so I need to find out where that is. And so what we need to do is evaluate what is y, right, at x equals 0. And so let's see, where can I do that? I'll do it right here. What is y at x equals 0? And so when we plug that stuff in, we got to do the cosine -1 of 0 plus 0. And so we need to evaluate, when does cosine equal 0? And so cosine equals 0 in this case, if we're going to use in radians, it's pi over 2 or 90 degrees. When you think about your unit circle, right, cosine is 0 at 90 degrees on that unit circle, right? When you rotate here, your cosine equals 0 here. Up here at top, sorry, it's sloppy, pi over 2. And so now we have the y value. So we're looking for the equation of the tangent line at 0, comma pi over 2. Now we know it's a horizontal because the slope is 1, but I just want to finish this because I do y minus y1. In this case is pi over 2. And I don't need to because I know the slope is 0, but I'm just going to go through it. And then m, which is 0 times x minus 0, right? This is what we call the point slope formula. And so in this case, you get your y equals, after you do your multiply and distribute, move the pi over 2, so your equation is y equals pi over 2. And there was a question, I think, on Pronto around this, that I think there was a typo on the solution. So there's the equation of your tangent line.